ID, the Future, a podcast about evolution and intelligent design.
Welcome to ID the Future. I'm your host, Andrew McDiarmid. Today, I'm excited to continue my conversation with Dr. Eric Hedin on the finely tuned origin and availability of metals for human use, and how metals play an essential role in the cellular processes that keep us alive. Dr. Hedin is Professor Emeritus of Physics and Astronomy at Ball State University in Indiana. He is author of the book Cancelled Science: What Some Atheists Don't Want You to See. He speaks regularly at universities around the country and writes on the evidence for intelligent design at evolutionnews.org. Dr. Hedin, welcome back.
Thank you very much, Andrew. It's great to be with you here again.
Well, we're discussing a series of 3 articles you wrote earlier this year for evolutionnews.org. And in the first half of the conversation, we discussed the cosmic origins of metals and the confluence of conditions required to make metals accessible to us. We also discussed the crucial role of metals in life's cellular processes. Today, I thought we'd go a little deeper into the history of our use of metals and what it reveals to everybody that studies this about the moral character of human nature. Now first, let's briefly review some of the points we made in part 1. We discussed the journey through space and time that metal elements traversed in order to arrive at planet Earth, revealing multiple phases of fine-tuning to make these essential elements available for our benefit. And you describe a confluence of conditions, great phrase there, that make metals available to us. Can you briefly recount that for us?
Well, I'll give it a try here without taking too much time, and that's a bit of a challenge, kind of reviewing the history and development of the universe from the origin of the Big Bang all the way up to present time, and try to do it in about 60 seconds. But yes, we discussed in our last episode that metals began in the cores of stars. They would have stayed there unless the more massive stars went through the process of exploding at the end of their lives in a so-called supernova explosion, which then not only spreads the interior contents of the star throughout space, releasing those metals to become part of a place like our own solar system, but also the energy released in that cataclysmic end to the star's lives in the supernova explosion provides enough energy to overcome the energy barriers required for the fusion of metals heavier than iron. And so those metals also become a part of the aftermath of a supernova explosion and eventually end up becoming part of the solar system that we live in, and in particular this planet. So astronomers have kind of unpacked this process over the years, but also what we've found is that this particular planet was also enriched with metals near the surface, meaning on the crust, and that's important because then they become accessible for human use. And that enrichment took place by means of a period of heavy meteoric bombardment in the early history of planet Earth, in the early history of the solar system. Asteroids, kind of planetary debris left over from the formation, began to be dislodged by interactions with the more massive planets gravitationally, and a lot of that debris rained down on the surface of the Earth and became resources, metallic resources that we're still using today. So there's a long process. We can look at that and see a huge degree of planning, you might say, of intentionality. To just describe it all as a happy coincidence doesn't really, I think, match the level of utility that we find with metals.
Right. Now, another thing we talked about is that the interactions between metals and microbes here on Earth has been beneficial to advanced life. This is part of the fine-tuning that has allowed us to safely utilize metals. Can you just briefly touch on that again?
Well, certainly, and again, from my reading on this topic, it's also a vast and deep topic that there's different aspects to it, and one of it is that living organisms, microbes, single-celled bacteria, researchers have found have been critical, essential in, I guess you would say, transforming the metallic ores and the metals that are on Earth into a form that is, one, not as toxic for life, meaning transforming them into non-soluble versions, but also making them accessible. So, for example, we use a lot of iron as the result, as the basis for our technology, and much of our iron comes from certain formations called banded iron formations, which are laid down geologically by the result of bacteria action. We then access iron through this as kind of we're a beneficiary of the results of bacteriological action. So it's an amazing process. And then we also have metals within our own cells that are critical for example, enzymatic reactions.
Yeah, and that was going to be my next thing to touch on here as we quickly review. We talked about the fascinating idea that life is dependent on just fractional amounts of metal atoms in cellular biochemistry. These metals are vital to our existence, it turns out, and that's not something we can chalk up to an accident, is it?
Well, I think not. And in order to enforce the idea that the way things turned out and how metals are so critical for cellular processes upon which our life depends, a little analogy might help. In any sort of a piece of complex functional technological equipment, for example, something we're familiar with, say a DVD player, it's often the case that just taking away even a single piece of the whole device renders the thing completely useless. If you go into the interior of a DVD player and you just say, well, let me pull out this electronic component, or perhaps this laser, or this wire that powers the motor that turns the disc, or any of the other components, the thing just doesn't work. And so that's usually the way it is with highly engineered systems that are designed and optimized to fulfill a certain function. And we see that exact situation within our cells. And so by analogy, it, I guess, is logical to conclude that our cells are exhibiting evidence of engineering design, but at a much higher level than anything humans have ever made.
Right. Yeah, it's not just that these things are complex by themselves, it's that they're interrelated with all these other components to the extent that you take one thing out, and as you say, the whole system stops working. And that is a hallmark of irreducible complexity and of engineered systems.
Right. And just to emphasize that, we can look at any sort of a natural system, a system that formed naturally, and we do not see that sort of delicate interrelated connections between all the components. Take anything natural, like a glacier. You can take away any number of water molecules. It doesn't affect the glacier, or a pile of dirt, essentially a mountain. Taking away, adding some dirt doesn't change anything. And pretty much anything that forms naturally has that aspect to it, that if you add or remove or rearrange the components, it's still pretty much the same thing.
Yeah, that's a great insight. Well, in the third article in your series on metals, titled The Discovery of Metals, a Double-Edged Sword, you get into more detail about the conditions within ourselves and the conditions within our environment that allow for us to utilize metals. First, what conditions within ourselves were needed for us to capitalize on metals?
Well, within ourselves, we have to, as humans, have the ingenuity to be able to imagine that there would be something useful that could come out of, say, generating as hot of a fire as we can and putting these metallic ores into it. And really the beginning of the whole process of metallurgy. In one book that I was reading, the entire book on the history of metals in humans said that this kind of original discovery of the processes of metallurgy, and the quote was, must stand as one of the great achievements in human history. It called for a stretch of the imagination, allied perhaps with intuition that even now, with the clarity of scientific hindsight, we find difficult to explain. So metals often are needing a transformation. They need some work from the raw ingredients to put them in a form in which they're useful. Human intelligence was kind of at a match for the challenge that was required.
Right. And it didn't have to be that way. It's what you'd expect in an intelligently designed system, but not necessarily one that came about through natural processes.
Exactly.
Well, what conditions within our environment needed to be finely tuned to allow for our successful use of metals?
Well, we've already touched on, just a few minutes ago, the conditions that really began clear back in the origin of the universe with the production of metals. But, fast forward to the time when humans are on the Earth, and in order for us to be able to successfully use metals, they have to be accessible to us. The metals or their metallic ores need to be available on the Earth's surface or near the surface of the Earth, and to be able to be mined and brought forth. And then it turns out there's a match that is required also. I mean, most metals need to be melted, and the ores need to be smelted, and there has to be a heat source that can obtain temperatures that are high enough to melt the ore in the metal. And it turns out that burning carbon-based materials, in particular charcoal or coal, allows humans to be able to obtain those required temperatures for the smelting of metals. And so it's an amazing match of chemistry, of the heat that's produced. It's requiring the oxygen content of our atmosphere to be within certain levels, and it's requiring the source of fuel, being able to have carbon-based material available to burn, and then it is also a match with the particular melting points of the materials that we're needing to work with.
Yeah, we cannot take these things for granted.
And it's so easy to take it for granted, but once you sit down and think about it all, you realize, wow, there's a lot of things that have to exactly match up.
Yeah, no, that's true. And that therein lies the value of articles like yours, where you can unpack that and remind us, hey, these are finely tuned conditions that we cannot take for granted. Well, as you review the history of humans utilizing metals, you quote biochemist Michael Denton from his book Firemaker, adding detail to the conditions necessary for the successful smelting of metals from their ores. Denton writes this: "It is only because charcoal reacts more vigorously with oxygen than uncooked wood, making possible the high temperatures in kilns and furnaces, that the extraction of metals from their ores and the development of metallurgy was possible at all." And adding fortuity to fortuity, burning charcoal not only provides the necessary heat, but also the reducing conditions in the kiln that strips the oxygen from metal ores, an essential element in the smelting and metallurgy of iron. Now, Denton's books are a great resource to learn more about planet Earth's fitness for human life, and he has a whole series. It's the Privileged Species series, and I highly recommend those to readers. They're very short, but they pack a punch. Have you found Denton's work useful to you in your own research and study?
Oh, yes, I certainly have. And, I have a great debt, I would say, intellectually and with my understanding from Denton and his writings. And I really appreciate the thoughtful research that he has put into such a variety of topics. There's the one we just were talking about called Firemaker. And he's outlined many other conditions, both within ourselves and the environment, that are necessary and have to be within certain ranges in order for us to make use of fire for, say, metallurgy. So he's gone into much more depth in his books, but his other books as well. The one about Children of Light, how light is so important for us in terms of our survival in biochemistry and so on. And I would certainly recommend the whole series to anyone who's interested in going a little deeper on this.
Well, as you point out, our dependence on metals continues to this day. The development of technologies associated with consumer electronics, renewable energy, and specialty steel have all sparked demand for a range of these special mineral commodities that just happen to be available for human extraction from the Earth's crust. These include rare earth materials or elements, platinum group elements, graphite, tin, germanium, beryllium, zirconium, and others. Are metals the gift that keeps on giving? Why are they so useful and precious to us even today?
I mean, that is I think, an intriguing question, and I believe that there's something even more to unpack there. But just starting with how many different metals there are that probably most people who don't have a background in chemistry, say, or geology, maybe a lot of these metals are just almost completely unknown. Even just today, I was looking at a list of some of the rare earth metals, the so-called lanthanide metals that are useful in a variety of high-tech applications. And there's 15 of these. There's a certain row in the periodic table of elements, which, we've all heard of that. But most of us, are familiar with some of the more life essential things like carbon and oxygen and, hydrogen and so on. But we may know about iron and gold and silver. Are we familiar with cerium or praseodymium? I can't even say this one. Praseodymium, neodymium, europium, gadolinium. And so some of these metals are crucial in our electronic technology. Cerium, for instance, is used as a catalyst in refining petroleum, which is essential for powering most everything we do. Another power-related metal is gadolinium, helps to capture neutrons in nuclear reactors. One of these articles that I was reading described, in their words, even another so-called Goldilocks zone. I mean, this is code word for fine-tuning. Whenever anybody says a Goldilocks zone, they're saying it has to be just right. And this author, again, spoke those words or wrote them, Goldilocks zone, and it was describing the so-called lanthanides, which have a particular electron shell structure, which is important for their use in magnetic and the luminescent properties of these rare earth elements. So yes, in a way, I think metals are the gift that keep on giving. It's, I think, at a point today that's far beyond anything our ancestors would have dreamed about in terms of what we've discovered and what the different metals that we find on the surface of the earth enable us to do in terms of new technologies.
Yeah, so crucial to us in human history, but also today. I think that's fascinating. And as you're saying, that's one of the reasons I appreciated your series, was just kind of exposing us to all these different metals we take for granted or we don't even know about, that all have, uses in our society, but, just in nature in general. It's great to learn about them and be reminded of them. Now, you also touch on how our use of metals exposes the moral character of human nature. And that's an interesting dimension of this as well. What can you tell us about that?
Well, this was a thought that began to come to me as I was doing a lot of reading, background reading about history of human usage of metals. And one of the things that came out in terms of the historical study of the relationship between humans and their discovery of metals says that minerals or metals have defined key periods in technological development for much of warfare's history. So the Stone Age, you had mineral-tipped spears and arrows. The Bronze Age included swords and shields of bronze. Bronze is not a pure element, but it's a metal alloy of combining usually copper and tin, a small amount of tin. So that was used in warfare. You can even read in the Old Testament of the Bible about the usage of bronze weaponry. And then, of course, that eventually became displaced by the Iron Age, in which iron replaced bronze in many weapons. And even today, up until today, iron and its alloys, making steel and so on, and other lighter weight alloys are still an essential part of weaponry. So I believe that this gift of metals, as we've called it here, also it's not just a free-for-all, but for us it comes with a level of responsibility. And again, sort of, if you think of, if you have a family and children, the gifts we give to our children when they're very young are usually completely innocuous. But as they mature, the gifts that we might give to them, on their 10th birthday or their 14th birthday, they're more interesting, and they also begin to carry a higher level of responsibility. And so I think that humans, as we've advanced, you might say, technologically, we have access to more of the advanced gifts of metals, but also with them comes responsibility. And perhaps that's been true throughout human history. Sometimes we do abuse the gift, and that's getting into the whole moral side of human nature, which probably takes us beyond the scope of this discussion. We can be thankful for metals, but there's a responsibility to use them for good and to use our moral responsibility to avoid using them for evil.
Right. And as you say in your title, a double-edged sword, right? Can be used both ways. Well, speaking of gifts, one of the most precious metals that so many of us know about is gold. And you did touch on gold a little bit, calling it the good metal. Can you explain why gold is the good metal?
Well, yes. We just discussed the possibility of using metals in weaponry. Yet gold, for all of its value, and it's been known to humans for millennia, is really not a weapon. Gold is valuable, but it's not much good to try to make a sword out of gold. It's gold is malleable. You can work it, and you can hammer it so it's very thin, and you can shape it to different background textures, for example, in gold plating and so on. But because it's soft, it's not going to be useful for trying to make a cutting element out of it, or even a shield. And so it's sort of, by its own nature, unavailable for doing harm in that way. But it is extremely valuable in our technology. Its high electrical and thermal conductivity are almost unparalleled. And so it is currently used in high-tech electronic applications. So I just found that interesting. Also, if you kind of look in the biblical literature, in descriptions even of heaven, it talks about the city was of pure gold. It's like, okay, there's some obvious good associated with that picture description. And sure enough, in the reality of gold as a metal that we use here on Earth, it also has properties that you could call it the good metal.
Yeah. Well, the confluence of conditions required for humans to discover and utilize metals, and the crucial role metals play in maintaining biological life, seem to point to foresight and planning and preparation. Is intelligent design a more likely explanation than a Darwinian process?
Well, I believe so. As a scientist, a physicist, I've often maintained that luck is not a valid scientific explanation. And when we see all of the, I would call it almost purposeful elements of what we've been talking about, the availability of metals are coupled with conditions within ourselves that allow us to make practical use of it. All of those point more to design, to kind of insert a worldview trump card there and say, oh no, it must be simply luck because there is nothing else. That I don't believe is really supported by the evidence. I was just thinking of this shortly before our conversation today. There's this fictional story titled The Swiss Family Robinson, first published in 1812. And the author, Johann David Weiss, wrote of an island where he employed a lot of kind of artistic license and called upon the readers to exercise fictional suspension of disbelief in order to kind of conglomerate and incorporate every resource imaginable onto that island that the marooned family could possibly need to transform their existence into a paradise, which they ended up doing. Our situation on Earth actually seems to be the real story of that. If we need something for developing some technology or need something that will serve our purposes, it's available. And so it's like our environment, the Earth that we've been raised on, is kind of an analogy to this story of the Swiss Family Robinson, and everything we need to thrive and develop technologies that are, today they would seem magical to our ancestors, but the availability of metals is a key part of that ability that we have to develop those technologies.
Yeah. Well, I, for one, have really enjoyed unpacking your article series on metals and life. It's given me things to think about that I have taken for granted and not realized. So I really appreciate you taking the time to unpack that and for continuing to write for evolutionnews.org. It's such a great resource. Thank you for sharing with us today, Dr. Hedin.
Well, thank you very much. I've appreciated the opportunity to go a little deeper with these topics.
Well, we'll include links to Dr. Hedin's article series in the show notes for this episode. And if you didn't catch part 1 of this conversation, be sure to go back and listen. I also encourage you to read Dr. Hedin's book, Cancelled Science. You may not know it, but some years back, Dr. Hedin was enjoying a productive career as a physics professor at Ball State University until an atheist campaign to cancel him and his Boundaries of Science college course occurred. His book, Cancelled Science, of course, tells that dramatic story, revealing the evidence the atheists tried to bury and hide, and explores discoveries that have revolutionized our understanding of the nature and origin of matter, space, and even time itself. So if you like the content we've been touching on here in these episodes, I really think you'll like Cancelled Science. Well, thank you once again, Dr. Hedin, for ID the Future. I'm Andrew McDiarmid. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.